Hi, I'm Professor O'Donoghue. Today I want to talk to you about while loops. So first, I would like for you to consider this scenario. You're about to wash your car, so you need a bucket of water. You go over to your faucet and you fill the bucket. The water continues to run until the water reaches the top of the bucket. Then you turn off the faucet. This is very similar to a while loop. We could code this experience. Think about it this way. When you go to fill your bucket, you have a condition. The condition is you want the water to run and fill the bucket until you get to the top, till the water level gets to the top of the bucket. Then you want to stop. So if we coded this, we would have to create some variables, right? We would have to create some conditions, and we would have code that would repeat over and over and over until that condition became false. In this situation, we would create a variable called bucket is not full. So it would be called not full. As long as not full was true, then the water would continue to fill the bucket. But as soon as the condition became false, which means the bucket is full, the water would be turned off and would no longer fill the bucket. All right, think about that for a minute, and then we're going to go through our lecture notes for today. Okay, so let's look at our lecture notes. So first of all, the first question is, what is a while loop? Well, it's a loop that's used to execute a block of code of statements repeatedly until a condition becomes false. When that condition becomes false, the code in that block stops executing. What's the structure of a while loop? Well, first of all, you initialize the variable that you're going to use to set your condition. All right, then you use the keyword while, lowercase while. In parentheses, you put your test condition because you want this code underneath it to continue to execute while that test condition is true. Once it becomes false, it leaves the while loop. You have your brackets, and then you have your statements that are going to be executed repeatedly. Now, do not forget, you must increment or decrement your variable in this block of code because your variable has to keep changing. And then once you go back up to the while loop to test the condition again, it's going to test to see if the condition is still true. All right, what does the flow chart look like? You have your test expression. If it's true, you execute the while loop. If your test expression is false, you leave the loop and you go on to the first statement outside of the while loop. All right, let's look at some examples. So here's the first example. So this program is going to print the value of the variable count while it is less than or equal to 4. Okay, so let's look at our code. All right, so right here we have initialized our variable count and it's starting out as 1. All right, next we're going to come down here and create our while loop. All right, so we have the keyword while, and here's our test condition. Count must be less than or equal to 4. If that is true, we go into the body of the loop. And I even have a little test statement here that says the program has entered the loop. That lets us know we're in the while loop. Okay, it's going to print the comment. Count is, and it's going to print the value of count. And I'm going to change this is to equals. Okay. Then right here, we increment our variable. Okay, so every time we execute this block of code, the variable is going to be incremented by 1. And we're going to stay in this loop until count becomes less than 4. Okay. Once it becomes less than 4, we're going to leave the while loop and we're going to go to our next statement outside the while loop, which is a printf statement that says the program has left the loop. All right. So whenever you're writing your own code, it's very helpful sometimes to put these little helpful printf statements, because sometimes you can get caught in an infinite loop or you may never enter your loop. And so when you have little print statements like this, it helps you to better debug your code. All right, let's look at it in code blocks. All right, so I have put my program in code blocks. So let's build and run it. All right, so let's see what happened. So if we look, the first line says the program is now inside the body of the while loop. Count is equal to 1. That's the first time it went through the program. Then it went through the second time. Count was equal to 2. It went through the third time. Count was equal to 3. It went through the fourth time. Count was equal to 4. Then on the fifth time, you notice it didn't go inside the loop. There is a message that says the program is now outside of the while loop because count is equal to 5 at this point. So it left the loop and it went to the next statement outside the loop. All right, back to our lecture notes. Our next question is, why is this program an infinite loop? So let's look at the program and analyze it. All right, it says this program will print the value of a variable while it is greater than or equal to 5. All right, so let's see what's going on. We come into the main function. We initialize our variable. It's called number, and it's equal to 6. That's what we initialize it to. All right. So now we come down to our while loop. All right. Here's our condition. While number is greater than or equal to 5, we are going to printf. The program has entered the loop, and then we're going to print the value of number. Then we're going to increment it, and we're going to continue to repeat this loop while number is greater than or equal to 5. All right. When number is no longer greater than 5, we will leave the loop and we will come out to the first statement outside of the loop. So let's run the program and see what happens. All right, I've created the program in code blocks. Let's build and compile it. And then it's going kind of slow. Here it is. Look at that. It's going on and on and on. It's never stopping. It's in an infinite loop. Let's stop it. All right. It's in an infinite loop because look at our condition. While number is greater than or equal to 5. Well, we'll initialize number to be equal to 6. So it's always going to be greater than or equal to 5 unless we decrement it down here in the code. But we're not decrementing it. We're incrementing it. So it's getting bigger every time. It started at 6 and it's just going on forever. So you have to be very careful inside your code whether you increment or decrement. A better option for this program would have been to decrement the number, or to increment it, to initialize it starting perhaps at 1 or 0, and then go up from there, incrementing. So think about these things when you're writing your code. What is the best course of action? All right, now let's go back to our lecture notes and look at our third example. All right, we want to know why this program, while 3, is an infinite loop. So let's look at what it's supposed to do. This program will print the value of the variable number while it is less than or equal to 10. So let's go down into our code. Here's main. Here's where we initialize the variable number to 5. Okay, so it's less than 10 to start with. All right, so here's our while loop. Here's our test condition. Number is less than or equal to 10. While that's true, the code that we're going to keep executing over and over is going to be to print that the program has entered into the while loop, and then to print the value of the variable number. Now, this time, we're going to decrement each time we go through the loop. All right? Once we leave the loop, once number is less than 10, what's going to happen is going to say the program has left the loop because number is, and it's going to tell you the value of number. So let's run it and see what happens. All right, so I've put the program into code blocks. Let's build it and compile it. See what happens. Oh, look at this. It looks like we're in another infinite loop. It keeps going and going and going. Look, negative 1100, negative 2000. All right, so let's just stop this loop and analyze what has gone wrong. So let's look at our condition. Our condition is while number is less than or equal to 10. Well, look what we initialized number to. We initialized it to 5. So it started out less than or equal to 10. And then in our code, we're decrementing it. So it's going to always be less than or equal to 10. Right? So it's never going to leave the loop. It's going to stay in the loop infinitely. All right, back to our lecture notes. So here's the next question. Can logical operators be used in the test condition? So just like relational operators, we can also use logical operators in our while loop test conditions. Some of the following scenarios are valid. You can use an and, logical and. You can use a logical or. You can use not equal to and. So you can use any of the logical operators, just like you could use the relational operators. So let's look at our final program. So I want you to think about what the output of this program would be. Well, let's look at it for a minute. What's going on here? Well, I'm already telling you in the comment. It's going to print the values of I and j until both conditions in the test are false. Okay, so both conditions are false in the while loop. All right, so this time we have two variables and we're using a logical operator. So what we're saying is while I is less than or equal to 4 or j is less than or equal to 3, we're gonna go into the loop. We're gonna print that we're in the loop. And then we're going to print the values of I and j. We're going to increment I. We're going to increment j. All right? And we're going to continue to do this over and over until both conditions are false. All right? So let's run the program and see what happens. All right. So here's the program. Nope, here's the program. All right. I put it in code blocks. Here it is. Let's build it and run it. Let's see what happens. Okay, so we start out and our first statement is the program has entered the loop. I is equal to 1, j is equal to 1 because that's what we set them for to start with. Then the second time through the loop, I is equal to 2 and j is equal to 2. All right, so then you go back up here. The conditions are still true. I is less than 4, j is less than 3, so we're going to go through the loop again. The third time through, I is equal to 3 and j is equal to 3. So we increment, we go back up. All right, so I is still less than 4 because it's 3. J has to be less than or equal to 3. Well, it's equal to 3. So we're going to go through the loop again. So we do. And what do we get? I is equal to 4 and j is equal to 4. All right. So now when we come back up here and test again, now I has to be less than or equal to 4. It is less than or equal to 4. Or j has to be less than or equal to 3. Well, j is greater than 3. It's 4, but because this part of the condition is true, we go through the loop again. So we print it, and we get I is equal to 4 and j is equal to 4. All right. We increment them again, so now they should both be equal to 5. We go up to our while loop. I has to be less than or equal to 4. Well, it's equal to 5, so that condition is false. Or j has to be less than or equal to 3. Well, j is equal to 5. So the second part of the condition is false. So the entire condition is false. So we drop out of the while loop to our printf statement. And here's our printf statement. The program has left the loop because I is equal to 5 and j is equal to 5. All right. All right, so that's it for while loops, and I hope that this video really helped to clear it up for you. I suggest that you go ahead and write a summary. Writing a summary helps you just solidify what you've learned in this lesson. The main takeaways are that for a while loop, you have a condition. You test that condition at the beginning of the loop. If that condition is true, then you execute the loop. If the condition is not true, then you don't execute the loop. All right, take care. Bye.